Hey everyone, welcome back to the channel. My name is Disu and you're watching Data Science with Disu. So this video is regarding data visualization in Python. So in the last session we have seen data wrangling in Python, in which we have seen using different kind of data set, how we can clean them, how we can create new features, how we can analyze them. So all of these things we have seen in the last session. So in terms of analyzing the data, we have not seen too much, because I'm going to create another video that is actually exploratory data analysis. So we will be looking at how we can do an end-to-end analysis of any data and how we can find out meaningful insight out of that. So that part will be coming later, but before that we have seen data wrangling, and now in this session we are going to learn how we can do data visualization in Python. Like whenever you do any kind of analysis for your data, so you have to represent the analysis through charts, graphs, so that it will be visually appealing and it will be easily understandable that what you have find out and what we can conclude out of that. So before we start this session, make sure you hit the like button so that it can reach out to the more people like you and they can also learn the data science domain. So without getting any further delay, let's get started. Okay, cool. So you can see I have started the notebook with a sentence called "a picture is worth 1,000 words." So what does it actually means? So that actually means that if you have somebody in front of you and you are explaining something to him or her, so when you explain something to them in terms of words, you might be using thousands of words to explaining that concept. But when you use a picture, a simple picture in front of them, so that picture can help them to understand the concept in a more clear way and without using thousands of words. So just for the example, I have given a subset of data. You can see there is a year column and there is a total, let's say it is a revenue column in terms of crores. So you can see in 1950 there is 752 crores of revenue, but in 1955 it is 839. So in terms of number, you can see that it is increasing actually. So for a lesser amount of data, you can easily analyze this. But when it comes to a data that is having thousands of rows, let's say not thousand, let's say hundreds of rows, even then you will find it difficult to understand that how the trend is increasing, like the revenue trend is increasing or going down. So you will find it very difficult to analyze just by looking at the numbers. But when you create a charts out of that, let's say for all the years you are plotting the total revenue. So in terms of charts and plots, let's say this is a line plot, you can easily understand now that from 1950 the revenue is actually increasing up to 1980, but after 1980 there is a downfall, very less amount of downfall, and then again it is increasing and again a little downfall. But after, you can see from here, like around 2005, there is a rapid growth in the revenue. So this is how a graph can help you to understand the thing very easily. So that is why data visualization is very important in Python. So how data visualization helps in understanding patterns and trends and a relationship in data. So data visualization helps in uncovering patterns, trends, relationship in data by providing a visual context. It allows analysts to identify correlation between variables, so detect outliers, explore data distribution. So all of these things I will be explaining you that what are those things, outliers and data distribution and correlation between variables. All of these terms I will be explaining you one by one. So visual representation like line plots, scatter plot and histogram enables users to intuitively grasp the underlying structure of the data, leading to more informed insight and decision making. So the more deeper you understand the data, the distribution of the data and the trend of the data, more deeply you can analyze them and make insight out of that, which will eventually help you to make decisions. So all of that plot, line plots, scatter plots and different kind of plots and charts, I'll be explaining you one by one. So before that, we need to understand the two libraries, that is Matplotlib and Seaborn, which is very important in terms of visualization of data. So whatever the visualization of data we'll be looking at, we'll be using these two libraries, either Matplotlib or Seaborn. So let's start with simple line plots. So before using the plots, you have to import the library. So you can see that Matplotlib I'm using. So import matplotlib dot pyplot. So inside matplotlib, that is a dot pyplot, and using that I'm importing that library, and I'm using an alias that is called plt for matplotlib dot pyplot, and I'm also importing numpy library because I need to create some range of array so that we can plot them as a line plot. So first of all, I'm going to import the libraries. Now we are going to create a simple line plots. So if you are plotting a line plot in a two-dimensional format, so you already know that there are two axes in 2D. So let's say x and y axis. So whatever the value in x axis and whatever the value in y axis, all of those points, let's say there are coordinates, and if you join all the coordinates, you will be getting a line. So that is the thing that we are doing. So we are creating an array that is x, and that is np dot arrange 5, that means the number from 0 to 4. And again we are creating another array that is x multiplied by 2, that means whatever the array element we have in x, we will multiplying by 2 to get the y array. Since we have two arrays x and y, now we can create a plot using plt.plot, and we will be passing x and y coordinates. So these are just numbers, x and y coordinates. It will be taking the corresponding element of x and y, and it will be plotting in a 2D format. So you can see 0 0, then 0.5, and then 1, because it is 2 times now. If x is 0.5, so y will be 1, but actually this is not a number in x. X is having 0 1 2 3 4, but since it is a continuous line, it is also showing that 0.5 along 0.5 you have 1, and 1.5 along 3. So but actually you have x 0 1 2 3 4 5, so 0, then 1 2 3 4, not 5 actually. So corresponding to 0, 0 into 2 0, 1 into 2 2, then 2 into 2 4, and then 4 into 4 4 into 2 8, like that. So you can see if you connect all of these points, you will be getting a simple line that is called line plot. So this is just a simple example that I am giving you how you can plot a line using array of numbers. But in actual, if you have any data, so in data, if you want to create a line plot, so what you have to pass out, you have to pass the x and y coordinates. So x and y here will be what, some values of columns. So whatever the columns you have, let's say there are two columns in between, let's say the same thing I have shown you now, total and year. So in total, for each year you are having total revenue. So let's say x is year and y is total revenue. So you can pass that column here in line plot x and y, and you will get the revenue trend for each year. So that is how you can create a simple line plot. But you can also create multiple line plots. So this was a single line plot, but you can also create a multiple line plot. So how you can create a multiple line plot? So same thing, first of all you have to import the libraries. Then let's say I am creating a x and y two coordinates, then again I am plotting that x and y, and again I am creating another coordinates, let's say x1 and y1. This is the combination of another coordinates, and again I am passing in plt.plot, but this time I am passing another argument, like third argument. X1 and y1 is the same thing as we pass x and y, but there is a third argument, that is actually what type of line you are. If you don't give any value here, it will be by default solid lines. But if you pass something in let's say inverted commas, so that will be the type of line that will be executed here. You can see this is the type of line you have. So this is the second plot that we have. So since it is not actually a straight line, why? Because the points are actually not matching, like 2 3 4 6, these are just a random values of numbers. So if you are having random values, like, so it will be plotted like corresponding to x equals to 3, y equals to 2. So this is x3, y equals to 2, then x equals to 6, you have y equals to 4. So that is how each point has been plotted, and it has been combined, like this one, and then this one, then this one. So there are 1 2 3 4 points we have. So it doesn't look like a straight line, but it is a zigzag line. So that is how you can create a multiple line plots. Inside a same plot, you will be creating multiple line plots. So those are the simple examples that I have given with the help of arrays that we have created. But in actual, how it look like this is the one. Why it is not visible, the dark one? Let me make it visible. Let me make it light. Yes, you can see this is the total number of sales, and this is the date. So you can see a day wise trend of this total number of sales for anything. Let's say this is the car sale, so that this is the trend that we are having. So this is how you can analyze that for each day how the sale of the car is going up and down. So this is how you can analyze. And this is the sales for the month of July 2018. So in July 2018, this is how the sale is going up and down. So this is the trend of that. Again, you can also create a multiple line plot. So you can see this is a simple trend we have, but you can have multiple line trends. So what does that mean actually, multiple line trends? So it might be happening now that whatever the car that you are selling, it might be of different type. Let's say petrol cars, let's say diesel cars, let's say electric cars. So for all type of that cars, you can create the trend line and how the sales is going up and down for each of these different kind of cars. So that is how you can create multiple line plots. Next, we are going to import a data set. So first of all, I am mounting the drive here. So connect to Google Drive, then choose the account, then continue. So here it is, the mounted add content drive. So drive has been mounted. A library I have imported already, but again importing. And this is the data set that I am importing from my drive. So it is actually menu data set. So you have already seen in previous session what is that data set we have. But if you want to look at it how it look like, so you can see, I will show you menu df dot head. Sorry. Yes, so you can see this is the data set that we have. So these are the item ID, then item name, then item description, then item type, price, ingredients, calories, rating, sales count, and cost per item. So these are the columns that we have for the menu data set. Now what we are doing, we are creating another feature that is called revenue. So out of the column that is already present, item, price, and sales count, we can just multiply them together and we can get a column that is called revenue. So I'm running that thing, and I'm also removing the revenue that is having value equals to 0. Why I'm removing that? Because I have to find out the gross profit margin, which is actually revenue minus cost per item divided by revenue. So since you are dividing by revenue, if it will be having a 0 value, it will give an error because of the division error by 0. So I have just removed that. Now it is fine. So now I can just do menu df dot head, and you can see there will be two new columns that has been added, revenue and gross profit margin. And gross profit margin actually in percentage, because I have multiplied with the 100. And this is the revenue column that we have. So let's start with bar plot. So we are going to learn how we can create bar plots. So what is actually bar plot? So bar plots are used to compare categorical data or to display the frequency of categories. So you may have some of the data that is having categorical feature. So if you want to find out the for each category what are the different values that we have. So for each category type you can create a bar plot, and you can see the numbers, like you can see the frequency, then you can see the some of the aggregate values for those categorical variable. So you can apply group by functions to find out some of the aggregate values, and then you can plot a bar plot. So I can show you how you can do that. So let's say we have menu df, and for each item type, since you have a item type column, so let's say for each item type we want to find out what is actually revenue that we are getting. So revenue means we are getting average revenue. So since for item type dessert, there are many dessert that we have. So for each of these item type dessert, we will be finding out, we will be summing up all the revenues, and then we will be dividing the number of items that are having item type dessert. So in this way we will be finding out the average revenue for that item. So that is why we are applying a group by function. So you have already seen what is actually group by function and how it works. So you can apply that and you can find out the average of that revenue. So using dot mean, and you can see this is the data set that we are getting. So for each item type we are having a revenue which is actually average revenue. So for the data set that we have created, we have given a separate name for that, average underscore revenue underscore item dot type. So we can use that data set and we can create a bar plot. So how we can do that? So there are actually two types of bar plot. We have a vertical bar plot, and then there is another which is horizontal bar plot. So first of all, we are going to look at vertical bar plot. So first of all, we are going to start with the fig, which is actually plt.figure. So this is the figure that we have, and why we are doing that? So that we can set the width and height of that figure. So whatever the bar plot that you are creating, you can uh, choose the size of that bar plot, so that you can manipulate that and you can make it bigger or smaller, whatever you want. So for now, we are creating width as a 8 and height as a 4, and then plt dot bar. So this is the syntax that we have for creating the bar plot, and then you have to just pass out the two columns on which we want to create the bar plot. So the first one is what? The first one is the categorical column that we have. So average revenue item type, this is the data set that we have, and this is the item type column which is having the categorical values. So we are passing that, and the second one is the what? The average value that we have. So we are passing that as the second, and this is the width. So this is actually controlling this width of the bar plot, and then you can give the title of the bar plot, then x label, y label. So what is that thing? This is the title that we have, and this is the x label, and this is the y label that we have. So you can just put out that x label and y label, whatever we have, and at last you have to do plt.show. So this is how you can create a bar plot. So you can see the, let's say for whatever the figure that you have created, let's say it's a bigger in size and you want to create a smaller size. So you can just reduce the size of that fig width and fig height, and it will be adjusted. So you can see if I just rerun that, it will be creating a smaller one. So that is how you can control the size of the figure, then width of the bar plot, then also the font size of whatever the title and the label that you are giving. All of these things you can control out. Now this is not just a single way of creating the bar plot. You have many syntaxes for creating a bar plot, and that depends on your use case, what type of bar plot you want, and you can create all of those kinds of bar plot using different kinds of syntaxes. And you not need to actually remember all of these syntaxes. You just need to understand that how it is working, so that you can manipulate that syntaxes and you can use for your use cases. So when you want to create different kind of bar plots, you can just search on the Google, or you can use the help of AI and ChatGPT, and you can give the prompt that what kind of bar plot that you want, and you can get the syntax for that. And you can also refer the official documentation. So you can just search on the Google the documentation of Matplotlib library, and actually matplotlib.pyplot and Seaborn, and in that you can find out the different kind of syntaxes that you have for different kind of plots, and you can just refer that thing. Cool. So this was a vertical bar plot, and you can also create a horizontal bar plot. So what is the difference between them? Just the bar h. So here you are using plt.bar, and here you are using bar h. So plt.bar h. So if you do that thing, you will be creating a horizontal bar plot. So it depends on your use case, what type of bar plots you want, and what type of visualization is more attractive to you. So you can create whatever you want. Next, as I've already told you, that there are many types of bar plots. So there are stacked bar chart, then there are grouped bar charts. So it depends on your use cases. So let's say you want to create a bar plot which is of passengers. Let's say this is the different kind of passenger vehicle that we have. Let's say 2-seater, 4-passenger seater, 5-passenger seater, then 6, then 7, then 8, and this is the frequency of that kind of car that we have. And the color is actually what? It is representing the different categories of car. So let's say it may be compact car, large car, mid-size, a small, a sporty, and one. So you can see for 2-seater car, it is mostly a sporty. That is why it is only having blue colors, and you can see it is a sporty. But for let's say passenger car having 4 passengers, so it might be like a sporty car also. There are many sports car that is having 4 seats, but there are mainly small cars that belongs to that, and there are also cars that is mid-size and compact cars that have 4 passengers. So that is why this is the distribution that we have. So this is how bar chart can help you, not just the distribution of category, but also the distribution of subcategory. So you can also represent that thing. and there is another grouped bar chart. So inside that, what is that thing? So let's say you have different let's say you are testing the mileage of four-wheel drive and front wheel drive and rear wheel drive cars, and you are testing the mileage in city, then in highway, and also at different rpm, let's say. So you can see, let's say this is a high rpm testing. So what you have in that case, that these three things are fixed, that you are having, you are testing for four wheel drive, front wheel drive, and rear wheel drive. But it may be possible that it is in the city, it is in highway. So for that cases, you can use grouped bar chart, where you are having always three groups of bar charts together, and it will be showing the distribution of average per drive. So let's say this is the actually mileage that we have. So let's say for four wheel drive, if it is in city, it is what, around 20, let's say it is a kilometer per liter. So this is the 20 kmpl. But if you are running a front wheel drive in the city, it will be having a higher mileage as compared to the four wheel drive and the rear wheel drive. So that is how you can just conclude from these group bar charts. So again, it depends on your use cases, that what kind of bar plots suits you in different situations. So I have just shown you the different kind of bar plot here, but I'm not showing the syntaxes, the codes of Python codes that is actually used to create this kind of bar plot. Why I have not shown you? Because for now I just wanted to clear the concept of a different kinds of visualization that you have, and I don't want to confuse you for now with that syntaxes. So I'll be actually showing you the syntaxes, how we can create different kinds of bar plots like that. But I'll be actually using the real data on which we'll be doing EDA, that is exploratory data analysis, and at that time we'll be looking at the syntaxes, that how we can create these kinds of charts. So for now, just understand that what are the different kinds of charts and plots that we can have with the help of Matplotlib and Seaborn library. So next we are having histogram. So what is actually histogram?